Now the idea behind this question is that it gives you potentials. They give you potentials of 2 volts and 3 volts. So potentials are at a point. So this 3 volt is at this point. Can you see connected to this point? This 2 volt is also connected to this point. And this is 5 volts, this is 0 volts. So all these are called potentials because it's single point. But from the potentials, we can find the PD. Because if this is 5, this is 3, the difference is 2. 3 and 2, difference 1. 2 and 0, difference is 2. So the PD between each of the resistors given as 2, 1, 2. Now since these 3 are connected in series, so they behave as a potential divider. So therefore, remember in a potential divider, your V is proportional to your resistance. So the V will be same ratio as a resistance. So if the voltage has a ratio of 2, 1, 2, the resistance must be a ratio of 2, 1, 2, which is C. You can see that, of course, 4 to 4 gives you the ratio of resistance, which is the same as ratio of PD. So the next question, in this circuit, you will notice you have 2 parallel combinations, this and this, and they want you to find the PD between X and Y. So X is connected to this point, Y is connected to this point, so you want to find the PD between these 2 points, which are on different parallel circuits. So how do I do that? So the idea is to find the potential difference between X and Y. You must first find the potential at X, then you find the potential at Y, then you subtract. Do you understand? So the question is, how do you find the potential at the point? To find the potential at the point, the technique is to use a potential divider formula first to find the PD. From the PD, we can find the potential. Now, the question is, if I want to find the potential X, for example, I can either find the PD from the top or the PD from the bottom. But which will be easier, to find the PD from the top or from the bottom? Now, some people will say top because there's only one resistor. Some people will say bottom because this is 0 volts. So which is the better idea? Now, both also works. Okay, both also works. But it's just that if you take PD from the top, you have slightly more working. If you take PD from the bottom, slightly less working. Now, why? I'll explain to you. Now, if the cell has 2 volts, that means the potential difference between these 2 points is 2 volts, right? Because 2 volts is EMF, and EMF is the type of potential difference. That means it's the difference between 2 points. So this is positive, this is negative. So let's call this 2 volts and 0 volts. Now, of course, you can give it any other values. You can give it 3 and 1, 5 and 3, right? But it's easier if you give it 0, unless you have no choice. You put one end to 0, then the other one is just 2, easier. So if this is 2 and this is 0, it means that this whole line is all 0 volts as well, because there's no resistance in between. And if this is 2 volts, the whole line here is also 2 volts because there's no resistance in between. So to find the potential at X, we can find the PD from either the top or from the bottom because we know the 2 potentials here already. But it's always easier to take from the 0 side. Let me tell you why. Now, let's say you calculate the PD here and you get 2 over 3 volts. Let's say you calculate the PD here. But how do you calculate the PD here? You use the potential divider formula for these 3 resistors in series. So you take 5 over 15 times 2 and you get, let's say, 2 over 3 volts. Now the PD here is 2 over 3 volts, but it doesn't mean X is 2 over 3 because the difference here is 2 over 3 volts. So the difference between here and here is how much? The difference between here and here is how much? 2 over 3, right now? But this is 2, so you must take 2 minus 2 over 3 and you will get this potential, which is 4 over 3 volts, right now? Okay, you get this potential as 4 over 3 volts, which you could have obtained easily if you take the PD from this side, which is from the 0 side. So let's say I want to take the total PD across here. So I combine these 2 into one resistance, which is 10. So 10 over total resistance 15. 10 over 15 times total PD 2, I get 4 over 3 volts, right? So what it means is the PD between these 2 points is 4 over 3 volts. Since this is 0, the difference is 4 over 3, so this has to be 4 over 3. So you see, I don't have to do any additional calculation. But if I found the PD from the top, I must take 2 minus the PD I found, which is 2 over 3, to get 4 over 3. But if I find PD from the bottom, the PD 4 over 3 is already the potential here, because this is 0. So always use the potential, to find potential, always use the PD from the 0 side. That's the technique. Less working. Okay? Now, give it a try. Now try to find the potential at y. To find potential at y, same thing. You find the PD from the 0 side. That means find this PD. So you will get 5 over 15 here times 2, and you get 2 over 3 volts. So the difference here is 2 over 3 volts. That means if this is 0, this is 2 over 3 volts. So no need to do any additional subtraction. So this is 2 over 3 volts, so this is potential at y. So potential at x is 4 over 3. So what is the PD? Between x and y, you subtract. And you get 4 over 3 minus 2 over 3, which is 2 over 3. The shortcut, if you don't want to do this method, is you must be able to see that this parallel circuit is identical to this parallel circuit right now. In other words, the potential at x, which is this point, is supposed to also be the same potential here along this parallel circuit. The potential here and here must be the same because it's identical right now. So instead of finding the PD between x and y, you can take the PD from here to here. And then you can straight away use the potential divider to find this PD, which is 5 over 15 times 2. You straight away get the answer. Okay, that is faster, but you need to be able to see that this circuit is identical to this. So in this case, you want to find the PD between x and y, you can actually find the potential at x and find the potential at y. But to be able to find the potential at x or y, you need to find PD first. So you need to set at first 12 volts between these two P and Q. You can either choose this as 12 and 0, or this be 0 and 12. It doesn't matter. But no matter what happens, you find the PD from the 0 side. Example, if I call this 12 and 0, if I want to find the potential at x, I find the PD of the resistance from the 0 side, which is this, 1000 ohm. So this will be in series, 12 volts. So what is the PD across this? 1000 over 1005 times 12, which is 8 volts. Then to find the potential at y, I find the PD from the 0 side again. So it's 1000 over 3000 times 12. And I get 4 volts. So if the potential at x is 8, potential at y is 4, so the difference will be 4 volts. So to find the potential difference between S and P, alright, because you want to find the V1 minus V2. So V1, find the PD here, and V2, which is PD between S and Q. Now you notice so weird, the S and P okay but why S and Q? But doesn't matter, because I was telling you that if it is 2 volts, you can take this to be 2 volts and this will be 0 volts, right now? And throughout the entire line here, it will be 0 volts. Understand? And throughout the entire line here will be 2 volts. So if they want you to find the PD between S and P, no problem. Find S and Q also no problem. It's the same as finding this PD. So just find this PD and just find this PD and subtract. So let's find V1 first. V1 is a PD between S and P. So V1 will be 5. Actually, no need to do this also. You know why? Because the 2 volts will be divided equally, right now. Okay, but if you wanted to show, you can, but it's a bit redundant. Times 2, so you get 1 volts. Or you can see that straight away that this is 2 volts, so split half-half. So this will take 1 volt. So if this is 1 volt, then find the PD across this 3 kilo ohm. So let's call this V2. So V2 will be 3 over 5 times 2 volts, which gives you 1.2 volts. So therefore, when you take V1 minus V2, so you get negative 0.2 volts. Okay. So you want to find the PD across M, P, and Q. So let's see how you adjust, how you assign the values of potential. So since this is 20 volts rise, negative, positive, so I take this as 0, I take this as 20. So if this is 20 here, so there's a 7 volts drop. So from 20, it dropped by 7. So 20 minus 7 gives you 13 volts here. So this point is 13. Then here it drops another 4. So 13 minus 4 gives you 9. So, but this one is always 0. So you want to find the PD across M, which is here. So 13 minus 0. So it's 13. PD across P, which is from here to here. So 20 minus 9, which is 11. And then PD across Q, which is 9 minus 0 is 9. So answer is C.